2017 November sequences. The following video introduces some traditional greetings: waving, smile, handshake, nods, kissing, clapping, first fist bumping, bowing, curtsy. Okay, all right. Number of females 2, 3. Number of kisses 2, 6. Okay, to everyone their own culture. Um, Number of males 1. Number of females 1. Number of bows 1, 4. Number of smiles 1, 4. Okay. 5 male colleagues and 5 female colleagues have gathered an important meeting. Okay. They all greet each other. Table 1 below shows the number of different greetings exchanged when male and female colleagues meet. The following notation is used. M represents the number of male colleagues, F represents the number of female colleagues, K represents the number of kisses, B represents the number of bows, S represents the number of smiles, G represents the total number of greetings, that is to say the number of kisses, smiles, and bows, okay, all together. Right, makes sense. For parts A, B, and C, you should refer to table 2. Write down in words 2 patterns from table 2 for the number of kisses. Okay, so this is table 2, right? Okay, this one is table 2 patterns. Okay, first there is a pattern of, there is a term to term pattern. As the number of females increases by 1, the number of kisses increases by consecutive even numbers. So this is what you can say. Because have a look. Here is a difference of positive 2. Here is a difference of positive 4. Here is a difference of positive 8. Here is an example of difference of positive, positive 6 and positive 8. But the second tier difference is the one that is constant. So this shows us that this is a primary example of, what do you call it, a quadratic sequence, right? Does that make sense? This is an example of a quadratic sequence. So
Yep.
we can say that as number of females increases by 1, number of kisses increase by consecutive even numbers. This is very important to talk about. So you see, plus 2, plus 4, plus 6, and plus 8. So that's the first pattern that we can see. Secondly, what can be another pattern? First is the general term to term increase. In order to describe a pattern, what can be another one? Look, 1 multiplied by 0 gives me 0. 2 multiplied by 1 gives me 2. 3 multiplied by 2 gives me 6. 4 multiplied by 3 gives me 12. 5 multiplied by 4 gives you 20. Do you notice the pattern?
Yeah.
Right? So we can say that each value of the number of kisses is basically found by multiplying the number of females by the previous integer. This can be the best way to put it. I'll write it here. I'll write the answer here. You can copy it down. Then I'll have to remove the answer. Okay. each value of k is found by basically multiplying previous number, yeah, multiplying the number of females with its previous integer. I'm sure, I don't know, in 2017 how many students might have sit for this exam, uh, but I'm sure they would have had a problem. You see, before 2020, I've noticed a pattern. Some questions of sequences were quite difficult, right? Remember the question we did yesterday, the one that was linked with coordinate geometry. Yeah, that was from November 2016, and in May 2016, we even had limits questions. So you see, this is something that happens. It's common. Write these both pieces of information down so that we can solve part 8, part B. I'll then remove these two uh, lines that I've written. Okay. The next part says, determine a general rule for the number of kisses in terms of the number of female colleagues. So basically, we know that the expression for the nth term for a quadratic sequence is given by n square plus an square plus bn plus c, right? So we have to find the values of a, b, and c in this case. So looking at what has been provided above, 0, 2, 6, 12, 20. 0 and 2 have a difference of positive 2, my bad. 2 and 6 have a difference of positive 4. 6 and 12 have a difference of positive 6. 12 and 20 have a difference of positive 8. But the common difference is of positive 2 between all of them. So this can be solved in this way. 2n or 2a equals to 2, 3a plus b equals to 2, a plus b plus c equals to 0. Alright, we did this in the quadratic sequences. So the value of a becomes 2 over 2, which is positive 1. A equals to 1. 3 times 1 plus b should be equal to 2. 3 plus b equals to 2. B equals to minus 3, which is negative 1. So b equals negative 1. C, let's find the value of c. 1 plus minus 1 plus c equals to 0. 1 minus 1 cancels out. So we have c equals to 0. So what sort of equation do we have? 1n square plus, sorry, minus 1n plus 0. But it says that it should be in terms of female colleagues. So instead of writing n, we'll just write f. 1f squared minus 1f, or simply f squared minus f. F squared minus f. The next part says, I'll have to erase all of this, so can I do it?
Yeah.
Okay. 8 part C says, verify your general rule. Okay, we don't need any sort of deletion. We can simply verify it by simple steps. F squared minus f, for testing part, we can substitute the value of 2. So when f equals to 2, so we have a 2 squared minus 2, which gives us the answer of 4 minus 2, which we have k value as 2. Let's say f equals 5. We have 5 squared minus 5, which is 25 minus 5, which is 20. So here we go. When the value of k is 2, the value of f is 2, the value of k is 2 as well. And when the value of f is 5, the value of k is 5 as well. So that verification part was pretty easy, not an issue. Okay, investigation. Write this down quickly, then we'll move forward to the investigation part.
I wrote that down.
All right. Investigate the general rules for the greetings when there are equal numbers of male and female colleagues. You can add more values in table 3 to support your investigation. You should predict more values and record these in the table. Okay, so looking at the sequence, there should be 6 male and female values. And as far as the number of kisses is concerned, so we applied the formula f squared minus f. So in this case, if we do 6 squared minus 6, we get an answer of 6 squared is 36. 36 minus 6 gives us the value of 30. Okay. Number of bows or bows, whatever is it called. Um, we can see another pattern. Should we solve the? Okay, we'll just at least solve the questions directly, or complete the table first, and then we'll care about what each and every individual question has to say. Uh, 1 equals 1 squared, 4 equals to squared, 9 equals 3 squared, 16 equals 4 squared, 25 equals 5 squared. So automatically I should know that the next value should be 36. 36 here and 36 there as well. And the total number of greetings, what we were told was that the total number of greetings is the sum of all of them. So if you want to verify it, you can verify it. 25 plus 25, that's 50. 50 plus 20 is 70. So look, three types of greetings, all of them add up to 70. 36 plus 36 plus 70. 36 plus 36 gives us the value of 72. And 72 plus 30 gives us the value of 102. So first we are done with all the predictions that we were supposed to do. Make sense?
Yeah.
All right. So at least we can say that we're done with this. Write down in words a pattern for S. S is the total number of smiles. Uh, I can say a pattern for S. It can be say it is equal to the square of number of males I think that would be an ideal approach. Simple. Equal to the number of square of number of males. Find a general rule for S in terms of M. Okay. S in terms of M. S in terms of M. Oh, that's pretty simple. Just the equation form of it. S equals M squared. Make sense?
Yeah.
Great job. Then it says find a general rule for G in terms of M. Okay, G is this. So let's say we have 2. This looks like a quadratic sequence, but let me check. I cannot be sure. The difference is of positive 8, positive 14. Yeah, it's a quadratic sequence. 20, 26, 32, 6, 6, 6, and 6. Okay. I know that the third tier difference should be equal to 2a. The second tier difference should be equal to 3a plus b. And the first tier difference is a plus b plus c. 2a equals 6 and a equals 6 over 2, which is 3. 3 times 3 gives us a value of 9. 9 plus b equals 8. The value of b becomes negative 1. And 3 minus 1 plus c equals to 2. 2 plus c equals to 2. C equals to 2 minus 2, which is essentially 0. So we have the equation of the line as 3n squared minus 1n plus 0. But it says that the general rule for G in terms of M. So instead of writing N, we should just write it as M. 3m squared minus M. That would be our general rule for G in terms of M. Alright? Write this down and tell me once you're done. Test your general rule for G. Okay, let's do that. 3n squared minus 1n. Let's substitute the value of 6. 3 times 6 whole squared minus 6. 6 squared is 36. So 3 times 36 minus 6. 3 times 36 gives us the value of 108. Minus 6 gives us the value of 102. 102. So testing is done. Then it says verify and justify your general rule for G. So essentially speaking, that's not very difficult. In order to contextually justify this, I know that each, the female kiss was given an equation as f squared minus f, right? And each male bow was given an equation of m squared, and the number of smile was also given the equation of m squared, right? But I know that the number of females and number of males are same, right? I know that the number of females and the number of males are same. So let me consider this value as m. right? Makes sense? I can simply consider the female as equal to male.
Yep.
So m squared minus m, and we have another m squared, and we have another m squared. If we were to add all of this functions, so all the m squares add with each other, so we get 3m squared minus 1m. And here you go. Here, our total number of greetings, it holds true for any number of equal male and female colleagues. Make sense?